Thank you very much. So I'm Hanan Lepek from Senecio Robotics, a startup from Israel. I couldn't ask for a more dramatic entrance than what just happened before. So I'm really happy to hear that she's okay. That was a dramatic moment. So yes, thank you very much for...
It's okay, don't worry. Thank you.
Thank you for having me here. Lots of interesting, great lectures today, very interesting day. So thank you very much. So I'll discuss in this presentation about about monitoring and classification and pooling of mosquitoes. And I will start with challenges associated with the current process, specifically about the challenges associated with experts doing this work. Currently today, at laboratories, experts are also doing a lot of non-expert tasks. We can see many of them in this picture. We have an expert in this image. So specifically, this one has a second degree, and he is doing a few non-expert tasks. He's separating mosquitoes one by one. He has a lot of paperwork to fill in. He's using his tweezers, and also once he did identify mosquitoes, he's putting them manually, one by one, into a vial for pooling. Also, he's identifying most of his time common mosquitoes. For the part that requires an expert, that is the non-common mosquitoes, it's actually a very small fraction of his time. So the expert is not utilized at its best. This is one thing. The experts today must be present on site. You cannot work remotely from your home. You must have an expert on site, even though many of these tasks do not require an expert, as I just explained earlier. And each person who does this work is on his own. What do I mean? He gets a plate, a dish of mosquitoes, and he needs to work on them, and nobody else typically see what he's working on and the mosquitoes he's working on. And if he's taking a break, I mean, he needs to work on this specific dish. All of those create a limit to the surveillance operation. It's not efficient, and you're limited by the number of experts that you have on site, and you're not utilizing your experts as you could have. So at Senecio, we are presenting artificial intelligence to streamline the process and work together with experts to leverage artificial intelligence, leverage technology to make the monitoring of mosquitoes much easier and enable scaling up and do it much more efficiently. We're separating between the simple tasks, the simple common tasks, and the tasks that are really, really needed to do by experts. So next, I'll need the organizer to switch to the video that we yesterday talked about, if that is possible. We need the organizer here. No organizer.
No.
Okay.
Give us a minute, please.
Yes, and I'm sorry, I will open your video, but I was far away from the microphones because I'm not the chair. So I will open the video.
I will show you now a short. I need to stop sharing.
Yes, please.
Okay, this is a short video from which is still relevant, how the process works, providing you the idea, and then we will deep dive into more details about the solution.
Spending too much time prospecting? Introducing Lucia, the perfect tool for any company size. Simply find.
Okay, no music here. Never mind. So what you have here is the mosquito trap coming back from the field. lots of mosquitoes in the trap. You need to identify each one of them. And that's a huge problem because lots of labor, as I just mentioned. And then we're introducing a concept how to streamline the entire process and also synchronizing it with on a map. We bring the trap, we put it inside the machine, which separate the mosquitoes and inject them on a moving conveyor. We then, as the conveyor moves, we then classify, we take images of the different mosquitoes and classify them, and then we also take them and later pull them into different files. We are rotating around the image, the mosquitoes to generate high resolution images to better identify the mosquito, to make sure that we have all the features of the mosquito that we need in order to identify it. And then we put it inside the file. So now that's a video that you're now seeing is actually on YouTube. We have multiple videos on YouTube from the company. You can just click on Senecio Robotics YouTube and you'll be able to see both that and a few other things that we are currently working on. I think you can now stop and I'll continue with my presentation. Okay. So who we are? We are an Israeli startup. We are building, leveraging automation and AI to scale up both production of both the monitoring and control. For the monitoring, we are building a complete automated sterile mosquito factory. Recently, we won the Horizon 2020 program for startups, and we are developing, building both an automated mosquito factory for scaling up of millions of mosquitoes per week. In addition to that, also a monitor solution, which is both relevant to SIT when you're having lots of traps on the field, and to anyone who's dealing with mosquitoes in monitoring. In 2019, we also won the first place for startups in Israel. So they discussed about how the process works. We are integrating our solution into the existing process. So you're taking your existing traps and then you're bringing, as I explained, to the lab, through the content into the machine, which then identify the common mosquitoes and perform pooling for the ones that it identified. And we upload the images that I'll show you in a moment into our cloud and provide access to the experts that then they will work on the images that the AI threshold was too low, so they are not one of the common mosquitoes, and now the expert will do expert work. The mosquitoes on the conveyor, so now we're deep diving a little bit more into the process. So on the left side, we see an example for a petri dish with lots of mosquitoes that came from a trap. And instead of using now the tweezers and separating them one by one, we place them inside the machine. And on the right side, this is a video taken from off the conveyor. You can see how they are moving nicely separated on the conveyor. The machine separates them and they are separated from one and the other, enabling the system to take the shots, the images from above in such that you can actually see different features of each of the mosquito. It looks like that. We take, and then we are using vision processing and neural network in order to automatically crop, identify the mosquitoes in the image and identify each of them. We then crop them, and then it looks like that. We send, we have high resolution for top view images. We send the images to a neural network model that we are teaching the computer to differentiate between each of the species that we are training it for. And then if the threshold was high enough, then we also, and it's a common mosquito, depending on the calibration by the technician, then we also put it into a vial. If the threshold was too low, meaning that most probably this was not a common mosquito, but rather a more rare mosquito that the machine was not trained for. Now we need an expert to do expert work. And then we are having a rotational camera that rotates around the mosquitoes, the insects. We know exactly what are the XY coordinates of each of the insects on the conveyor. So we rotate it in order to generate sets of high resolution images to provide experts the ability to access online by remote and view both the top view and also high resolution images from the side. And that would look something like that. And he can go between the different angles and the different views in order to see, to try to identify what are those, what species is it, depending on, I want to see the abdomen, I want to see the thorax. So he has lots of images around the mosquito and he can choose and then he can decide what it is. Not only that, once we rotate around the mosquito, in order for us to truly be able to provide sufficient data to the expert who gain access online to the mosquito images, and only by that be able to identify the mosquito, we also provide the ability to change the focus plane and generate different focuses of what he's looking at. For example, this is the left side, and then he wants to see a different body parts in different being in focus. So this is what you see on the right side, and all of that is through our proprietary online platform, in which the user see the trap content images, explore the different images, and then per each of them can see the different angles, and per each of the different angles can look at different focus planes of each mosquito. Then once for the ones that the machine automatically identified, they move on the conveyor to the next station. At the next station, we have a robotic arm. We know exactly what are the XY coordinates from the previous camera, top view camera, and then we send those coordinates to the computer, which then picks the mosquito and automatically place it inside the vial. What we see here on the bottom image is an image from one of our tests in which the robot actually put mosquitoes inside a vial. And now, no longer an expert should do any more tasks which are not really related to being an expert. He can do expert work, he can be located remotely. Once all the information was uploaded, as I explained, it's uploaded to an online platform where you can see information on the map, but you can also access the different images, generate reports, collaborate. Instead of single person, single expert, single technician that works with his petri dish, now all the team can go online and look at different images that all came from the single petri dish, and they can debate, ask for second opinion, and take sound decisions. We're targeting for all the common mosquitoes that we are identifying 95% accuracy. The throughput of what we've been able to achieve is very, very high, around the 1,000 insects per hour. We are doing automated pooling into vials. It's a compact, small unit, the size of a walking desk in your laboratory. And last but not least, we're also providing an API, planning and visualization tools to be able to export information and results from the system. In order to do all that, we're creating, I believe, a very unique data set. That's the largest, one of, or the world largest digital high-resolution mosquito repository of images, high resolution from top view, and from around each of the mosquitoes. We are receiving mosquitoes from Italy, from Slovenia, from Israel, from California, Florida, more and more and more and more, creating huge amounts of data, really large variety of species. Very, very interesting. Just recently, our first version was allowed for shipment to one of the leaders in the US, and it will be arriving soon to California, with additional ones hopefully to follow very, very soon in our region as well. So this is very exciting times in where we leverage artificial intelligence with entomology, in synchronizing work with experts, maximizing the work, and really enabling experts to do the expert work. And when there is no need for experts, when we're talking about common mosquitoes, common tasks, then this is something a robot can do. So this is very exciting for us. So this is me on the bottom right. If you have any questions, be happy to answer. This is my email. Feel free to email us. This is part of my team, and we are very excited. So thank you very much for having me, and I hope you also enjoyed the lecture. Thank you.